yourself so that we don't listen to your conversations? I can do that also myself. And then maybe, David, you could introduce Peter better than I could, because I don't know him very much. So
yeah, okay. Well, so actually I don't either. So I just had a short conversation with Peter just a second ago. So obviously we are very happy to have you here, Peter, in our course presentations, and I understand that there's also parallel sessions going on. That's actually the reason why you're here. So, but I think the best idea is that you give a short introduction of yourself and also of the company, because actually this is an important part of our series of presentations as well, that we not only take the academic points of view, but also look more to the industrial and applied point of view, because this gives extra information. We academics can find all kind of very nice and innovative solutions, as industry can, obviously, but in the end it will also has to be affordable, acceptable, and let's say practical. And I think for that reason that it is very nice that we have Peter here, who can fill us in on all these topics. Peter, the word is yours.
Okay, thank you very much for your kind introduction. Thank you for having me here. I'm really honored to be here among all these learned speakers as a simple electrical engineer. But very nice that I can give this talk for you. I have given it this title: Challenges in Developing a PV Plant or Wind Farm, the Engineering Perspective. But maybe it's rather a engineering perspective, because there are many aspects where engineers are needed, and we only do a very small part. But first, indeed, some introduction about my company and myself. The company is called WSP. It's a worldwide consultancy and engineering company. But even though we are worldwide, we try to be close to our customer and yeah, know them personally. But still, we can use the worldwide expertise that we have within the company. In the Netherlands, we have 10 locations. These offices were before Lievense and Petersburg Consultants, but we have become part of WSP only yeah, over the past few years. And in the Netherlands, we provide services for buildings, for infrastructure, for energy, for water, and for and the environment. And I'm in the energy department. So there's this slide. We have 50,000 employees worldwide, so very broad expertise we have available. And I have, from the template, I have kept the slide about the energy department. We do a lot of calculations for and design for high voltage infrastructure, also for pipelines. But more and more we have started to also provide services for PV plants and wind farms. And from that perspective, I hope I can add a little bit to this this course. Then about myself, I did a master in electrical engineering, but not in high voltage, but in microchips. Also learned about mechanical effects, optical effects, fluidic effects, everything you can do on a microchip. And then I had the opportunity to do a PhD research on solar water splitting. So basically integrating PV modules with electrolyzers, putting them in one device. That was a very nice idea at that time. Yeah, I enjoyed it very much working on it. But looking back, I think, yeah, it's not an idea that is really going to be used. because it brought a lot of challenges to bring these two devices that each already have their own challenges to bring them together in one place. And there are advantages if you can directly use your electricity instead of converting it to hydrogen always. So after that, I thought it was very interesting, but I wanted to do something where it was really clear that it was useful. So soon I was doing every day the same boring calculations, but our clients are paying very well for it. In the meantime, it has become a bit more interesting, but yeah, that's a little bit how it was for me to do very interesting things. But these are not always the challenges of every day in this energy world. But still, it's very useful research, of course. But yeah, it was quite a change for me to change to the engineering world. So there I have done a lot of studies about electrical influence of high voltage on nearby objects. I will talk about that in the second part of my talk. But we also have started to do more and more studies for PV plants and wind farms, and in these studies I have usually been involved. So that is why, yeah, I was asked to give this talk. So yeah, I have basically two parts in my talk. In part B, I will really talk about the things that I do, that I work on every day. But through this work with the wind park developers and construction companies, we also see a lot of the other challenges that they face, and sometimes we are able to help there as well. So I won't say that I can treat all challenges, but at least I want to touch on some challenges that are probably quite important in this field at the moment. And yeah, between and after, so after each part, I would like to do a question and answer section. So part A, challenges in the development process of PV plants and wind farms in the Netherlands, because yeah, some things are probably also similar in other countries, but this is at least something that I know something about. And I will talk about these challenges. One is finding suitable land where to put your modules or your turbines. Another challenge is the business case. An really important one is nowadays is the grid connection. And another challenge that I want to address is yeah, having to deal with a densely populated country where wherever you want to build something, you have to deal with the people that live nearby. Now, acquiring land was the first challenge that I mentioned, but actually it's not much of a challenge because, for example, a developer of a PV plant can easily offer more than 5,000 euros per year per acre to rent a piece of land from a farmer. Now, and there are some forms of intensive farming that agriculture that can earn more, but also a lot of land in the Netherlands doesn't give such high yields. And yeah, for many farmers, it's an easy choice, especially if your son or daughter doesn't want to take over the company when you retire, or when it's not as fertile anymore. Yeah, this is so. This is actually not really a challenge. Then about profitability, and the point that I want to make is that the Netherlands is not actually such a good location for PV. On the top left, I have put a map of what what is the potential of PV in a lot of locations over the world, and we see that if you put the same module in the Netherlands or in another country, it's better to put it somewhere else, because in a whole year you can generate up to 3 times as much electricity with the same module. But for wind, it's actually quite good, especially on the North Sea. We have some of the highest average wind speeds in the world there, and the North Sea is quite shallow, so it's a very suitable location for offshore wind. And it's also interesting because from there you can connect to the Netherlands, but also to the UK, to the Nordics, and share this energy. And so referring to the talk of Professor Lennart Söder this morning, this is a really interesting opportunity to balance the energy in this region. But also onshore, we have quite good wind speeds compared to many parts of the world. But still, it's quite hard to make it profitable. At the moment, we have a lot of subsidy money available for this. And you see that if you put a solar plant in the Netherlands, it's done a lot at the moment because of this subsidy, but actually only a quarter of your income will come from what you earn from the electricity that you provide, and the rest is subsidized. With onshore wind, it's a bit better, but still it cannot work without subsidy. At the North Sea, it's starting to become profitable without subsidy. But I have to make some footnotes here, because we have by law a flat rate in the Netherlands everywhere for obtaining a grid connection. So whether you are building your wind farm close to a big steel production company that can directly use the electricity, or close to a main high voltage substation from where you can easily transport your energy everywhere, or you are building it hundreds of kilometers out at sea, you still pay the same for having it connected to the grid. But of course, the latter option will be much more expensive for the grid operator who has to provide the connection. And they have to get this money somewhere. And as a society, in the end, we pay for it. So this is something. This is a price that is not included in the profitability of offshore wind. Then there is another challenge coming up, and that is that now that we have more and more renewables, we also get moments where the electricity prices become negative, where there is so much production that it cannot be consumed. And for those times, you don't earn anything from on the electricity market, but also you don't get this subsidy, because that is in the rules of this subsidy. If you have several subsequent hours of negative electricity prices, you will not get this subsidy for the power that you produce during that time. Also, at the moment, we have a bit of a smaller challenge, which is coming from how this subsidy is organized. It is done such that the subsidy is awarded first to the company that can provide the highest CO2 emissions for the same subsidy money. And at the moment, there are quite some nice opportunities for carbon capture and storage. We have some empty natural gas fields onshore and offshore in the Netherlands, and it's quite relatively easy to pump CO2 into them. And this is at the moment it's cheaper to avoid CO2 emissions in that way than by building PV plants or wind farms. So At the moment, this is a bit of a competition why there is probably a bit less PV plants being built. But soon it may become more challenging to find new empty gas fields for carbon storage. And then there will be more opportunities for wind farms and PV plants. Then this picture shows a really big challenge at the moment. For a long time, the electricity grid in the Netherlands was slowly expanded gradually with increasing demand. And the electricity was coming from a few power generators centrally placed. And in that way, everything worked very well. But then over the last few years, there was a rather sudden policy change where they introduced these huge subsidies for renewables. And also because we have this flat rate for grid connection, there is really no incentive for placing your generation, your renewables generation, close to consumption. So what you see is that it is being placed at locations where the land is cheap, and that is in rural areas. And in rural areas, you have a very thin electricity grid. So in a very short time, it has become quite overloaded. I show you this map, which was made by the Union of Grid Operators in the Netherlands, and it shows locations that are yellow, where they are at the moment expecting capacity problems. In the places where there is no color, there are no challenges at the moment yet. There are the red areas, and there it is already clear that no new connections can be provided at the moment for new generation units. And this has been recognized by the regulatory body that we have for grid operators. And the orange areas are basically almost red. The problem has been indicated, but the regulator still has to recognize that it's really not possible anymore there to provide new connections. And so this is really a big challenge at the moment, and it's by law the grid operators are obliged to provide these connections, but they simply cannot do it anymore. They don't have the manpower. The ordering of new cables and transformers takes too much time. And anyway, a project for a whole new overhead line or big substation, it can take 5 years or 8 years, while a new PV plant, starting from the idea to being operational, it can be done in 2 years. So this development is going much faster than is possible for the development of the electricity grid. And then there is this other challenge, and that is that a lot of people don't like renewable energy in the end when it's being placed close to them. Of course, a lot of people like the idea that we get free energy from the sky, basically, and we don't pollute the planet anymore. But once you start building it close to them, they start to be a bit more critical. And this is especially a challenge for onshore windmills, wind turbines, because you can see them already from large distances. With PV plants, it's a bit easier usually to hide them behind some bushes, for example. Now, and this is a challenge that by addressing it properly, it can be dealt with. In that sense, it is easier than the grid connection problem. If you start early in the process by involving stakeholders, by involving people that live nearby, if you give them the opportunity to participate financially or in some other way, or to give them the opportunity to give their opinion. And maybe you have to make some changes to your design, but yeah, if you involve the people more from the start, it's usually much easier to get them to accept your project. And this is something also where we can help as a company to address this in a proper way. And that is already my first part. I can talk a lot more about it, but maybe it's nice to talk about the things that you are interested in, especially. So I would like to hear if there are any questions already at this point. Let's see, can I also?
I don't see anything in the chat. Looks okay. Yeah, now there's something coming. There's a. Do you see the chat?
No, I don't see the chat. Oh, yeah.
There's a little window.
Yeah, I have now.
Perfect.
So someone is saying, I've never lived near a wind turbine. How loud are they really? I don't know. I haven't lived close to one either.
I don't think they're super loud, but I mean, you will never have a wind turbine in a distance from yourself that is against EU rules regarding loudness and other potential problems. So I think you don't have to worry, at least in the EU, about these kind of problems.
No, I think it's usually more the view, the landscape that is disturbed. Is something that is bothering people. And if you're really close, you get this, and when it is sunny, you get this shade every time that one of the blades passes. So that's supposedly also quite disturbing. But that's only if you live really close.
And Peter, I believe that there are also regulations for that, isn't it?
Yeah, there are, and there are standard ways of assessing this for wind turbines, and naturally they have to comply with this. And and that is also something typical for that an engineering company will do. That they will make this assessment and make sure that they are placed in locations where such that at a location of houses there is no the sound is not too strong.
There are other questions coming up.
Yeah, I see one about energy communities. So anyway, we see this that people are allowed to invest in a wind farm or a PV plant that is built nearby, and they will directly get a share of the profits made from the electricity. And there are these arrangements where you can even, if the PV plant is close to you, you can subtract your share of the production. You can subtract it from your own consumption in your house, and that is really nice because the price you pay for your electricity is for consumption, for buying it from the grid, is much higher than the price you would get for selling electricity from PV. So now the PV production will result in changes against the high tariff instead of making profits on the lower tariff. So that's really nice. but these kind of arrangements are also being phased out because, yeah, the renewables have to become more profitable by themselves.
I see there's also a question about grid stability.
If the wind farm cannot connect to the grid, how to provide stable electricity? So there all at the moment, of course, there is already stable electricity being produced by, for example, natural gas power plants. So if already before the wind farm is being built, the grid operator will assess if there is any, if it's possible to integrate this wind farm into the grid, and if at that point they already see that yeah, stable electricity or a stable voltage or a stable frequency cannot be maintained. If the wind farm will be connected, then they simply will not provide the connection. Or sometimes they make a deal like curtailment can be applied. So they get a connection, but at some points they are simply not allowed to deliver all their electricity to the grid.
Maybe take one final question, Peter, and then go on to your second part.
Yeah.
Time. That is the last question about the investment payoff period.
Yeah, so at the moment, also for households, if you put PV modules on your roof, you are allowed to subtract its production from your own consumption over the whole year, and then I think it can pay back within 7 years or so. I'm not sure about the exact figures, and now they are changing this to they are phasing out this system and still changing to another type of subsidy, and I think the payoff time would increase a little bit in that way, but like a few years. So I don't know, but I don't know by heart the exact figures.
Yeah, I think I agree with your numbers. 7 years currently, and it will become more if the subsidy rate or the subsidy regulations will change.
Shall I continue then?
Yeah, great.
Okay, so part B is yeah, rather specific, but I think a lot of you have a technical background, and so far I haven't really spoken about really technical challenges, and this is also something that I can tell a bit more about. So it's about the electrical influence of on metal pipelines. I was already saying shortly that the challenge is to deal with stakeholders, and I was so far mainly talking about people that live nearby. But another type of stakeholder is the operator of metal pipelines. In the Netherlands, we have a lot of pipelines. There is about 300,000 kilometers of underground pipeline in the Netherlands. It's densely populated, and yeah, even if you place your PV plant in a rural area, you still have a chance that it will be close to a pipeline. And especially the steel, only the steel pipelines are relevant for this electrical influence, and yeah, many dangerous substances or any substance that is transported under high pressure will the pipeline because it's strong, and gas molecules cannot easily diffuse through metal. So we have a lot of metal pipelines in the ground. There is a lot of noise from. Sorry, but
I'm trying to kill off the. Sorry. No, I killed you. I'm killing off No, I killed it.
Yeah, okay, thank you. Yeah, so these pipeline owners, they are a bit concerned about all this new electrical infrastructure and these new renewables generating plants that are being built, because these electrical systems can influence their pipelines, and this can lead to dangerous touch voltages. I have here also a picture of some above ground parts of the natural gas pipeline system. So if someone is touching it and there is a high voltage on it, that will be dangerous. Also, the voltages that occur on a pipeline can lead to increased corrosion. And these effects, yeah, I wasn't really aware of them before I started to work with this company, but they are actually quite a challenge sometimes, and it's really something to take into account. Yes, so let me explain about some of these effects. One of them is inductive influence, and this what happens is that if your metal pipeline is running in parallel with an electrical circuit. For example, this overhead line here in the picture, but it could also be an underground cable, could be a medium voltage cable inside a PV plant or one that is connecting a wind turbine. If it's running in parallel with a pipeline, it will generate magnetic fields because it's typically an AC connection. So changing currents will lead to changing magnetic fields, and changing magnetic fields can cause induction in nearby metal objects. And this is actually a really significant effect. During normal operation of an overhead line, if you have a pipeline close to it, you can easily get more than 50 volt AC on your pipeline, and this would be dangerous if you have an above ground part, and that could be touched, and also on average, the average AC voltage that you would have on your pipeline can cause increased corrosion, and this is already when it's above 4 volt. You have a chance that AC corrosion will occur. So we calculate this for all types of AC connections and pipelines that are nearby. So also for PV plants and wind farms. Another risk is that when there is a short circuit in the high voltage connection, you will have, for a short duration, if the protection of the high voltage system is working correctly, this can be less than 100 milliseconds, but still it can be dangerous. You have a very high current, which is going in one direction through your electrical circuit, and then it's going into the ground somewhere. And through the ground, it is returning to the source. And for this very short duration, it generates very high magnetic fields, and you can get much higher voltages on your pipeline. This can be like 2000 volts, even though it's only for 100 milliseconds. Your body could handle it for a very short time, but 2000 volts is still too much, probably. Depends a bit on what type of shoes you are wearing, and yeah, that kind of things, additional resistances. So these effects we study regularly. Then there is another effect. I was already talking about the short circuit. That the short circuit current, and this can be like many kiloamps, and that can go into the ground at a certain location. And the ground is a bit conductive, and it will, but still it has a rather high resistance. And if you have a current going through a resistance. I hope many of you know Ohm's law. Current times resistance will lead to a voltage. So you will get a voltage drop in the ground, close to the point where the short circuit current is going into the ground. You will have a very high voltage, and this is slowly decreasing to further away from the point of the short circuit. Now, if you have for example, if you have a pipeline in the ground close to this point where the short circuit can occur, then and by chance there happens to be a coating defect on the pipeline, or it's maybe an old degraded coating, or there is maybe some above ground part of the pipeline that is used to operate it, then the pipeline can assume the same high voltage of the soil at that location, and it can, because it's conductive, it can bring this voltage to far away from the location of the short circuit, where the potential of the soil is around 0 volts. And then you have maybe a voltage difference of 2000 volts between the pipeline and the surrounding soil. This can damage the coating, or if someone again is touching some part of the pipeline and standing on this on the ground, they will experience a very high voltage between their hands and feet, and that can also be very dangerous. So this is not something that we are sure that will happen. Of course, you do not want short circuits to occur, but they can occur, and yeah, we have to be prepared for that, because they do occur sometimes, and in that case, it still has to be safe. And then there is another effect that is, well, I wouldn't say specific for PV plants, because for a long time we have had DC trains close to pipelines, and it is already known that these DC currents can run through the ground and cause increased corrosion on the pipelines. But recently, pipeline owners have become more concerned that PV plants, which also have a lot of DC currents, that they will also cause these problems. And the main this is actually was very interesting for me. Of course, it's not nice if the pipelines start to corrode, but it was really nice for me to study this effect, because the pipeline owner starts to come with their concerns, and we have, for example, a developer of a PV plant which doesn't have this technical knowledge to explain to the pipeline owner why in their system there are not such high DC currents in the ground. So we really have to study these type of systems and think about where could you have a leakage current into the ground, how large could this current be. It is limited by the protection systems that are inside the inverters in the PV system. There should be a device that measures the resistance between the DC cables and the ground. And if this resistance becomes too low, there is an electrical leakage, and the inverter will shut off, and the owner of the plant will come very quickly to repair that damage, because if the inverter is shut off, they lose income. And there is another measuring device that is monitoring the difference of the current that is going into the PV string and the current that is coming out. And if this difference is too big, then also the inverter will shut off. But there is also always a bit of margin in this, because even the best cables will degrade a bit over time and start to leak a little bit of current, and this doesn't have to be a problem. So a little bit is always allowed, but these limits are usually based on fire hazard. They are trying to keep these leakage currents so low that there are no fire hazards. But that doesn't mean that these currents are low enough that they will not damage a nearby So we really had to start looking at these systems in a different way and think about where can the current go into the ground. And what we see is that it's probably the highest risk is from the DC cables that are put directly into the ground. Typically, these cables do not have an earthing screen. They only have a polymer insulation around them. And if these polymers degrade over time, or if they are damaged, then it is possible that larger currents will leak into the ground. And like with the short circuit that we saw for the high voltage system, you will get a voltage drop in the soil, and close to the point where the current is going into the ground, you will have a higher voltage, and close to the earthing system where the current is leaving the ground, you will have a lowered voltage of the soil, a negative voltage, or the other way around. So then you will have a change of the soil potential. Now, if you have a pipeline there with a defect or a degraded coating, and you have a voltage difference between the pipeline and the surrounding soil, you can also get increased corrosion of the pipeline. But again, this is a bit hard to assess, like which voltage difference can you allow. You cannot say like the PV plant has to produce absolutely zero changes in the soil, because you can never guarantee this, and you would have to place your PV plants kilometers away from any pipeline, and this is not realistic in the Netherlands. So we have been discussing a lot with pipeline owners, with construction companies for PV plants, with developers, like where can we reasonably put the limits, and how can we guarantee that that these limits are being kept by the system. Yeah, so there are a lot of there are a lot of calculations that we do regularly, but this new phenomenon is really something for which we had to do some research, and that was also really interesting. And yeah, that was my second part. So again, I hope there's still time for some questions and answers.
Yes, I think we still have some 10 minutes or so. I think there was still an open question from the previous session. That was, how long will it be before wind power and photovoltaic power do not need subsidies?
Yeah. Yeah, as I said already, for offshore wind, we are already at that point, I think. But it also depends on other things, like, for example, the price of storage, or how the balance is in the energy system. Are there opportunities to connect a PV plant together with a wind farm on a single cable? Yeah, so and all the regulations that are there for these to make these types of innovations work. Yeah, it depends on a lot of things, actually, of how they will actually be profitable. But I think PV will always be very hard in the Netherlands to make it profitable. But yeah, it also depends, for example, on a carbon price. As long as power is so cheap from for example, a natural gas plant. Yeah, onshore wind and PV can maybe never compete with it if the price stays like this. But if these plants have to pay more for the CO2 they emit, maybe it does become profitable. At least the electricity prices will go up, and you will earn more from your PV plant.
Okay. Yeah, just if there are questions, type them in the chat. And meanwhile, I may have I remarked that you had an interesting slide about carbon capture and utilization. That was cheaper in terms of euros per CO2 avoided than solar and wind. So that means that there is a risk that they get the subsidy instead of the solar and wind.
Yes.
Is that already going on at the moment?
Yeah, I am not really completely aware of all the latest developments, but a few months ago, at least, that was really a concern for the PV sector. Like, yeah, will it actually be possible to obtain this subsidy during this year? Because there are quite a few CCUS projects that yeah, that can avoid CO2 quite relatively cheaply.
Okay, so that's interesting. You get a competition between the renewables, and the competition is for the subsidy.
Yeah.
Yeah, interesting. Okay, well, I think that so far your presentation was actually quite clear. I don't see any.
Yeah, there's more, I think.
Oh yeah, there is more coming up. Yeah, what is the greenhouse gas emissions from producing a wind farm, PV farm is an area we should focus on. Yeah.
So you mean probably so not during operation, but already before to produce the modules and to construct it on site or to produce the turbines. Yeah, I don't know much about this this question actually. If I'm not mistaken, I think over the whole lifespan, they will generate more electricity than or more energy than it costs to make these wind farms or PV farms. So in that sense, but it has to be. Otherwise, it really doesn't make sense to make them. So in theory, you could have basically the first PV plant for which you need fossil energy. You can make it, and then you can use this renewable energy as the energy source for producing new PV plants. But I don't know any numbers here really.
Yeah, we can put it in the challenges. The students have to address several challenges. So I think this is an interesting question as well. It requires some research and going into available literature data, because I think indeed on production of wind farms and PV farms, there is a lot of data available about how much is the CO2 associated with the production of these and installation of these farms. Okay, yeah. Okay, then I think, Peter, would you be willing to share your slides as well, so I can put them up to the students?
Yeah, I can send them.
That would be great. So the slides will become available as all other slides for the presentations of this morning. And I guess thanks a lot, Peter, for